Hello everyone. Today what we are going to discuss about the example question 3.3 chapter motion in a straight line. You can read the question now. Obtain the equations of motion for a constant acceleration using the method of calculus. So just before doing this problem, we need to know what is meant by integration in mathematics. What is meant by integration? So we will be discussing first of all what is meant by integration. So let's go through the integration. For that, a force displacement graph. What I am drawing here, a force displacement graph. Say it as displacement is x, and say it as along the y-axis it is the force. Okay, a force displacement graph. Just imagine a force is applied on a body. And we are going to take that reading and we are going to draw the graph here. Just imagine on a body always the same force is applied. How you can draw the displacement force graph here? Always same force is applying on a body, so body will be definitely displaced here, right? So if the force is constant, we can draw a straight line parallel to x-axis, because the force is constant, right? Even though displacement is changing, force is constant here. My question is here, just imagine this is the origin, okay? This is the final point we are taking here. Say it as x itself. So this is the displacement graph. So this is x in meter and this is the final position x. What is the area under the graph? Can you calculate the area here? Definitely you can calculate very easily. You know why? Because the shape of the area is a rectangle shape. If it is a rectangle shape, you can calculate the area is equal to length into breadth. Here what is the length here? That is a displacement. Okay, so I can write here displacement. Now what is the breadth is equal to? Breadth is equal to this one. Definitely we can say that it is the force value you will be getting there. So displacement into force, or we can write here area of the rectangle is equal to what? Length into breadth. So we can write here area is equal to force into displacement. Area is equal to force into displacement. As you already know what is meant by force into displacement, that is equal to work done. So we can write here the area under the force displacement graph, you will be getting what? The work done. Okay, work done. So what I want to explain here, in this type of graph, it is very easy to calculate the area because the force was a constant value. Now you just imagine the force is not a constant value. Maybe one example you can say here, a cart is pulled by a man. While the man is applying a force on the cart, is it always the force will be equal? No chance, right? So just imagine the force acting on the body is always varying, and at the same time displacement is also increasing. So if you are drawing the graph, this is the force and this is the displacement. Force is varying in this example. What is varying here? Force is varying. And see the initial displacement from the origin, say it as A. Now let's say the final displacement is now say it as B. Okay, the force is also varying. It is not a straight line graph. My question is here, how to calculate the area under the graph here? Is it easy to calculate the area under the graph? No, because there is no definite shape here. So what we'll be doing to calculate the area? That is the question. So what we are doing here, in order to calculate the area, the whole area, what we are making here, we are making this one into very, very small strips. We are making into what? Small strips. Many small strips can be seen. If you are making small strips, you can see here in this case the force become a constant value. Now what is the displacement here? Say it as, I am writing it as delta x. So you can easily calculate the area of this rectangle. Now it is almost rectangle, that's why we made the small strip. But we require the entire area. So what we are doing here, we are making the entire graph or the entire area into small strips, same as delta x. Displacement is same, delta x only, but the force now you can see it is varying. I have drawn here few area only. Just imagine delta x are there, many are there. Now how to calculate the total area? So I can write here, if this is the first area, if I am taking, I can write here A1 is equal to F into delta x. Here what is a force? It's not a constant, right? In this case it is a constant value, but other values are different. So I can write here F1 delta x. If so, what is the A2 here? Consider this is the A2. So I can write here A2 is equal to, during that case the force is something different. You see this one? So I can write here F2 into delta x. So delta x is not changing. So all these distances are equal, just imagine. So if so, what is the total area? What is the total area? Usually what you will be doing? A1 plus A2 plus etc. till an. So here we can write here A1, A2, A3, every small area you are adding now. Is it an easy process to add all these areas? No. There we are using the other term called summation. So I can write this entire area. I can write here sigma I is equal to 1 to n AI. Can we write like this? Sigma I is equal to 1 to n AI. This is the entire area. The total area is equal to sigma I is equal to 1 to n AI. That is, we can write this equation as sigma I is equal to 1 to n. Now what is area? Area means force into displacement, where force is varying F1, F2, F3, etc. So I can write here Fi into delta x. So which is a variable here? Force. So I 1, 2, 3, etc. till n. So this is the way we will be doing usually the summation. But instead of this one, now we are going to use another term, another notion called integration. What is that? Integration. In that case, we can write this formula as the entire area A is equal to, instead of summation we are using another term like this, an extended S actually. Okay, integral, this is called what? Integral. We can write here F into delta x. F into delta x. So here F is the function of what? X. We can write here function of x, F into delta x. So this is the way to write what? Integration. Now one more thing you can add in this case here, that entire area you are taking from which position now? A to, here we have marked here B, right? So we can write the limit here, integral A to B f of x into delta x. Now in this case, while you are using integration term, we can write the entire area is equal to A to B f of x. Instead of delta x, now we are going to use other term called what? Dx. So we have discussed already what is a dx, right? Derivative. Okay. So dx we can write that. So this is the way of writing the integration formula. I hope it is clear. So what we have done in this example, if it is a constant value, force value, we can easily calculate the area. But something is variable. In this example, force is variable, right? Some other example also we can take it. So in order to find the total area from where? A to B, what we are making here, we are making into small areas so that we can easily calculate the length into breadth. And after that, you will be adding all this area, A1 plus A2 plus etc. AN. So definitely you will get that one. Just imagine these small areas are n times are there. There are n small areas are there. So is it easy to calculate? No. There we are using the term called summation. So we can write here summation sigma I is equal to 1 to n AI, where AI is called what? A1 plus A2 plus A3 plus etc. So what is area? Force into displacement. Here forces are varying, F1, F2, F3, etc. So we can write here Fi delta x. Okay. So now here writing A is equal to integral A to B F into delta x. It is actually wrong. While you are writing delta x here, it should be written about dx term. So just for understanding, I have written first delta x here. Now from what is the limit here now? A to B. That means it's changing from A to B. So that is called what? Limit, applying the limit. And this is called lower limit, and this is called what? Upper limit. Now you write the exact formula for integration. A is equal to, that is total area is equal to integral A to B, integral A to B F into dx, where here dx means what? It's a variable. Which variable? It's a what is varying here? Displacement. X is variable. So we have written the force is also varying for that. So we can write here force is a function of x into dx, where force into displacement is what? We will be getting the total area that is equal to the entire work done. So what is the final answer you are getting here? Work done, the total work done you will get. Okay. So instead of a small work done, after the integration, what you are getting now? The entire work done. Hope it is clear. Now for doing this problem, example 3.3, we require two equations of integration. Okay. So just to learn that formula only, so let me explain that two formula, what is required for deriving this equation. So the first formula required here, this is a formula you write, integral dx, integral dx. Answer, integral dx is equal to x. Integral dx is equal to x. Here the what is a variable? X is the variable. If I am writing integral dt, integral dt means what? The variable is time. So we can write here after the integration, you will get it as t. So what is a variable? After the integration, you will get that the total value, the entire value you will be getting. Now you just imagine, I am just explaining with the dx term. Okay. Integral, same formula dx. Imagine it is varying from 0 to 2, 0 to 2. That means an initial point is 0 and final point is 2. Or lower limit is 0 and upper limit is what? 2. We have already explained the previous graph from A to B. Same way 0 to 2 dx can be written as, what is integration of dx? That is equal to x. Here the limit you should apply, the answer should be right in terms of a square bracket. And you have to write here what is the limit here. 0 is the lower limit and 2 is the upper limit. After writing this one, listen carefully, after writing this one, first you apply upper limit in the variable. What is the variable here? X is the variable, right? So first of all, I am applying the limit into x. So x must be what? 2. So x, instead of x, if I am substituting 2, it become what? 2. Next point, minus. So we have substituted the upper limit minus. Next you have to substitute for what? Lower limit. Here what is the lower limit? 0. So if I am substituting for x 0, answer become what? 2 minus 0. So what is the answer become? 2 is the answer. So there is no unit. We are simply writing here 2. So integration, how to apply the limit here. First of all, write the integration formula, final formula. After that, substitute the lower limit and upper limit. After that, apply the upper limit in the variable minus lower limit in the variable. Just to substitute that value and you are getting what? 2 is the answer. I hope it is clear. Now let's discuss about the another equation what is required. Okay. Integral x to the power n. N means what? Power. It may be any number, okay? Simply write integral x to the power n dx, because we are writing here the variable is what? X is the variable. The general equation for this equal to integral x to the power n dx is equal to what? X to the power n plus 1. You are adding 1 with the power divided by n plus 1. So Please by heart this formula. Integral x to the power n dx is equal to x to the power n plus 1 divided by n plus 1. Okay, so just a formula is required in this case. Now just imagine if I am applying the limit, for example a to b. If I am applying the limit from a to b, x to the power n dx is equal to, I can write now in square bracket. If the limit is there, write in square bracket. X to the power n plus 1 divided by n plus 1, close the square bracket and apply the limit now. What is the lower limit? A, and what is upper limit? Here it is b. Okay, just do one example here. Integral, I am applying the limit from 0 to 2. So limit may be not always 0 to 2, okay, 1 to 2, 3 to 5, etc. Any value can come here. So 0 to 2, say it as x square dx. So power is equal to what? Instead of n, it is given the word 2. So the general formula we can write in square bracket because the limit is, we have to apply 0 to 2. X to the power n plus 1, here n is equal to what? 2. So what we can write the x to the power 2 plus 1 divided by 2 plus 1. What is the limit now here? 0 to 2. Then that is x to the power 3, 2 plus 1 become 3 divided by 3. The limit is now 0 to 2. Now, which is the variable here? X is the variable, right? So we have discussed here x is the variable. Maybe time will be the variable. Here it is x. So I can write like this. 1 by 3, I can take it outside because that is not varying, it's a constant, right? Now I can write in bracket, if I take the 1 by 3 outside, x to the power 3, now what is the limit now? 0 to 2. So I can write now 1 by 3 into, what is the first equation? We have to substitute the upper limit minus lower limit. Here what is upper limit here? 2. 2 in x. So I can write here 2 cube minus, now apply the lower limit. Instead of x, substitute 0. So 0 cube. So what is the final answer? 1 by 3 into 8 minus 0. So leave it. 8 minus 0. So we got the answer as what? 8 by 3. So this is a way to do the integration. Now let's move to our example question 3.3. Now let's derive the first equation of motion by the method of calculus. For that, we already know the formula acceleration is equal to dv divided by dt. dv divided by dt. That is, first derivative of velocity is called what? Acceleration. We have already discussed in the previous topic. Now you can rearrange this formula. I can write this formula as dv is equal to a into dt. dv is equal to a into dt. So here v is what? Velocity, variable, dv, variable, dt, time is also changing. Or we can write here, velocity is also variable, time is also variable. Just imagine for a uniformly accelerated motion, velocity is varying from initial velocity to final velocity. You can also substitute u to v, or we can write it as v0 to v. So if you substitute initial velocity as v0 and final velocity as v, here v is variable from which one? v0 to v into dv is equal to integral. Here what is a variable? Time is variable. Just imagine starting from 0 to final time is t. So initial time is what? We are taken as 0, and final time you can consider as a t itself. So into a dt. So integral 0 to t a dt. So we have written the integration formula. Actually we have written here dv equal to a dt. That means you will get a small change in velocity, you will get it. In order to calculate the entire change in velocity, what is required? We have to do the integration, summation. Instead of summation, we are using what? Integration. Now let's compare with the previous equation. Integral dx is equal to x, right? So integral dv is equal to what? It becomes v. So I can write here v. Now limit is the, so apply the lower limit and upper limit. v0 to v is equal to, now let's see here, a is a constant. you can take it outside. If you take the a constant, if you take it outside, you can write here 0 to t into dt, into dt. So I can write this equation as once again, v, limit is from v0 to v is equal to, now a is already there outside, you can write this one, integral dt, integral dx is equal to x, no? So here integral dt is equal to what? T itself. So we can write here t. Now apply the limit from where it is changing. The time is changing from 0 to t, right? So I can apply here lower limit and upper limit. Now what is the next step? Apply the upper limit minus lower limit. So for this variable v, substitute the upper limit. Upper limit is v itself, right? Minus apply the lower limit in the velocity. So it become what? v0 is equal to a into, now writing bracket here, first you substitute the upper limit in the time variable. So t itself, you will be getting it as t itself. Okay, we are not substituting any number, just t itself, minus apply the lower limit, it become what? 0. What is the final equation? V minus, or v is equal to v0 plus at. So this is the first equation of motion. We have already learned in previous classes, or maybe in year 9 classes, v is equal to u plus at. So this is the first equation, okay, or v is equal to v0 plus at. We have explained or derived by using the method of calculus. Okay, now let's move to the other one. Now for deriving the second equation of motion, let's write the formula. Velocity is equal to dx by dt. We have already learned this equation, right? Velocity is the first derivative of displacement, correct? Just refer the previous topic. Now we can write here this equation, if you rearrange, dx is equal to v dt. Dx is equal to v dt. That means small change in displacement is equal to velocity into small change in time. But we have to calculate the entire displacement. So what we have to done here? Summation. But we are not using summation, we are using the term called integration. So in order to do that one, just to do the integration, integral dx is equal to integral v into dt. Integral v into dt. X is a variable, here time is a variable. X is variable or varying from one value to other value. So write it as initial value is x0, final value is x. Here the time is variable, right? So I can write it as 0 is the initial time. So we are considered as t is equal to 0. Now final time is given as t. Now do the integration. Integral x0 to x dx is equal to integral 0 to t, what is v equal to in the first equation of motion? That is equal to v0 plus at for a uniformly accelerated motion, v0 plus at into dt. Now you can write this equation as integral x0 to x dx is equal to, open the bracket, I can write like this, 0 to t v0 into dt. I can write here v0 into dt plus, now you are separating the integration part, integral 0 to t at dt, at into dt. We can divide the integration part like this. Now once again same way, integral dx is equal to x, so we can write here x, limit is from here x0 to x is equal to, v0 can be taken outside, so v0 into dt, dt is equal to what? T, time t, from limit from 0 to t, plus, here a can be taken outside, if you take the a outside, it become t dt. T dt means what? X to the power n dx. So what we can write here? T to the power n plus 1, here what is n? 1. So 1 plus 1 is equal to what? 2. All divided by 1 plus 1, that is equal to 2. Use the other formula, x to the power n dx is equal to x to the power n plus 1 divided by n plus 1. Limit apply 0 to t here. What is the final equation? Upper limit minus lower limit. Upper limit minus lower limit in the given value is equal to v0 into upper limit you apply t minus lower limit same as t itself plus a 2 can be taken outside. If you take the 2 outside, t square from 0 to t. Apply the upper limit, it become t square minus what is the lower limit? 0 only, right? So it become what? 0. So what is the final equation here? X minus x0 is equal to v0t plus, you see this one, half into a into t square. So this is the second equation of motion. Or what is x minus x0? That is the displacement. Displacement is equal to v0t plus half a t square is same as what? We have learned that one. S is equal to ut plus half a t square, where x is a final position and x is 0 is what? Initial position when time t is equal to t1. Okay. So this is the second equation of motion derived by using calculus, the method of calculus. Now let's do the third part. For that again we are using the same equation. Acceleration a is equal to dv divided by dt. That is first derivative of velocity is called what? Acceleration. So for deriving this formula, we are writing or rearrange this formula like this. A is equal to dv divided by dx into dx divided by dt. Okay, so dx will cancel, so we will be getting what? Dv by dt once again. Now in this equation, what is dx by dt? Dx by dt is the first derivative of displacement, that is equal to what? Velocity. So I can write this equation as dv divided by dx into velocity, or a dx is equal to v into dv. It's a variable in the left hand side, dx. What is a variable in the right hand side? Here it is dv. Now what you have to do here? You have to do the integration. So left hand side if you integrate, what is the limit here? Variable is displacement, right? So I can write here x0 to x, initial position to final position. Here what is the variable here? Velocity is the variable, right? So I can write here initial velocity as v0 and final velocity as v. Now just to substitute just to use the integration formula. Left hand side, a can be taken outside, variable is dx. Integral dx is equal to what? X only. So I can write here x. What is the limit now here? x0 to x. Okay, is equal to, so right side v dv same as integral x to the power n dx is equal to x to the power n plus 1 divided by n plus 1. Here it become what? I can write here v to the power, what is the power here? 1 only. So n is 1. N plus 1, 1 plus 1, that is equal to 2, divided by n plus 1, that is 1 plus 1 is equal to 2. What is the limit now? What is the limit now? v0 to v. Therefore, if you apply the upper limit and lower limit, I can write this side as a into x minus x0 is equal to 1 by 2 if you take it outside. Here you can write upper limit is v, so v square minus lower limit is v0, so v0 square. Take the 2 to the left hand side, 2a into x minus x0 is equal to v square minus v0 square. Or simply you rearrange this formula, you will be getting what? V square is equal to v0 square plus 2a into x minus x0. This is the third equation of motion, same as v square is equal to u square plus 2as. Okay, I hope it is clear. So this is the third equation of motion. Thank you all of you.